Hello, in this video we will work out an example for using the constant multiple and the sum rule, which we learned in the previous video. So let's say that we want to find the derivative of this polynomial. So we want to find d of x. So just as a quick note, this right here means the derivative with respect to x. So if here, instead of having an x, let's say we had y, this means that we have to find the derivative with respect to y. In this case, since we don't have a y here, then we can just think of everything here as a constant, because as far as we know, x does not depend on y. Unless we are told otherwise, we would have to substitute. But in this case, let's say that we say that x does not depend on y. And so if that's the case and you want to get the derivative of this with respect to y, well, this is just equal to 0, because you can think of all of this, all the terms that depend of another variable that is not the one that you are finding the derivative of, that you are not finding the derivative with respect to. Well, you can just think of it as a constant, as a number. You can just think that x is equal to 3 and plug in a 3 for all x's, and you're left with only constant numbers. So, since the derivative of a constant, we know that it's 0, well, the derivative of this would be 0 with respect to y. However, it's not as easy. We do have to find the derivative of this polynomial with respect to x, and we see that the terms contain x, so it's not as easy as just getting rid of all of it and just saying that the derivative is 0. That was just a side note, and so let's work this out. So first, we can use our sum rule to define this derivative to be equal to the derivative of each term individually, and then adding all the derivatives up, like I mentioned in the previous video. That is what the sum rule is. So you have to get the derivative of 3 times x to the 4th plus the derivative, and all of this with respect to x. You cannot change the variable that you are derivating by when you're using the sum rule. You have to keep this constant. Then minus the derivative with respect to x of 3x, and minus the derivative with respect to x of 7 over square root of x. A quick note is that here you can see that I kept the either addition or subtraction constant, and that's actually kind of already using the constant multiple rule, since you can think of a negative as being the negative 1 times 3, and then so let me rephrase this. So if you have, for example, 6x squared minus 3x, you can just think of this as 6 x squared plus negative 1 times 3 times x, right? And so by keeping the sign, so by taking out the negative 1 and keeping here the subtraction, just like we had here, it's like it's an extension of the constant multiple rule. So we're already using it, and if you don't feel comfortable, you could just add all of them up and just have negative 3, and all of them up and here have negative 7. That's up to you. We would get exactly the same thing. Okay, so let's work this out. The derivative of 3x to the 4th, and this is where the constant multiple rule also comes in. So we know that this is just equal to 3 times the derivative of x to the fourth with respect to x. Then here we can bring out the 6. In the next term, we can bring out the negative 3. So here it's just easier to do minus 3. That looks like an equal. Okay, minus 3 of times the derivative of x minus 7 times the derivative of 1 over square root of x. See? Now we just have to find the derivatives of x to the fourth, x squared, x, and 1 over square root of x. And so we will just use our power rule to figure this out. So we know that the derivative of x to the fourth, so here I'm going to write the power rule just to refresh your memory. And so we know that the derivative of x to the fourth is just 4 times x cubed. The derivative of x squared is just 2x. The derivative of x is just 1. And the derivative of 1 over square root of x, I would like to show you that one. So 1 over square root of x, well, you know that this can be written as x to the negative a half, right? Because this is just 1 over x to the half, and when you have an exponent on the denominator, you know that to bring it up, you just have to make it negative. So this is our x to the n form, in our x to the n form. So n is negative a half. So we bring the negative a half down times x, and negative a half minus 1, well, that's just negative 3 halves. Like so. So here we have negative a half x to the negative 3 halves. Very well, now let's erase this. And now let's just simplify. So we have 3 times 4, 12. So we have 12x cubed plus 12x minus 3. And then here, see how it turns into a plus. So plus 7 halves x to the negative 3 halves. This can be written as 7 over 2 the square root of x cubed. Whatever you prefer, it's exactly the same thing. And so this is the derivative of the polynomial we got. And that's our answer. Feel free to work it out yourself. And as a additional note, I want you to see that your signs, like if it was a minus or a plus, doesn't necessarily carry on into the derivative. So you can see here that for these first 3 terms, if it was a plus, the plus was maintained, but in the last term, a minus turned into a plus. So just keep that in mind, that you actually have to work things out. You cannot just like predict what it's gonna be.